Hello there. In this video, we're going to talk about LDR or light dependent resistor. So basically, this component, or if you want to call it a sensor, is used to detect the light in any specific area. Couple of things we need to know about this LDR is that it is made from cadmium sulfide. Is nothing that we can use that information, but just as a general knowledge. And this is basically a big resistor. The way to test an LDR is using a multimeter. So let me show you what I'm going to do is, so we have a multimeter and we have the ground on the COM, and then we have the positive on the V, ohms and milliamps. So basically it's going to measure all of that. And I have my cursor pointing to the ohms, and I have it at 200 kilo ohms. Now obviously you can switch back and forth from 220 depending on the amount of resistance you want to measure. So I am holding the LDR in my hand with one pin. This is the positive, and I'm simply going to touch the COM with the other lead. So I have switched it to 20 kilo ohms because when there is a lot of light like I have now, it's not going to measure at 200 kilo ohms. It's going to be very small. So let's switch it to 20 kilo ohms and test the values, what it says. So right now it's saying it's about 3.54 depending on the light. So this is the value of the resistance at this amount of light. Now what we're going to do is we're going to switch off the light just for a second. The light is off, and if you measure now, it says 19, 18, and so therefore what we want to take away from this example is that as the light reduces, the resistance increases, and vice versa. This is the schematic of what we're going to do. So first is we're going to have LDR, which is a photoresistor, and we're going to hook it up to VCC, which is 3.5 or 5 or 5 volts from your Arduino. And then on the other side, we're going to connect to ground through a series resistor of 10 kilo ohms. Now in the middle, the voltage divider, this is where we're going to hook up our analog pin to A0 or A2, 3, doesn't matter, A0 to A5, any one of the pins. I'm just saying A0 here. So this is where we're going to measure the value of the voltage. I've already constructed the circuitry for this example. I will go over it real quick. So we have done exactly the same thing as shown in the schematic. So it is connected in series. The red wire is 5 volts, which is coming from the Arduino device, and it's going to one end of the photoresistor. The other end of the photoresistor is connected in series with one end of the resistor, 10 kilo ohms resistor, and the analog pin. The other end of the resistor is going to ground. So in other words, we have one end of the photoresistor connected to 5 volts, and the other end of the photoresistor is connected to the ground via a resistor, 10 kilo ohm resistor, and the voltage dividing point or the analog measurement point is right between where the resistor meets this LDR. Let's take a look at the code and run the code. So I've created a very basic code here. We have an integer called LDR, and we have void setup. I'm just printing to the serial, and in the void loop we are using the LDR variable we created, and I am assigning the value of the analog read to the pin number 2 as we saw in the schematic. So we are basically reading pin number 2, and then I'm printing that value to the serial. I'm delaying it by 500 milliseconds because then we will be able to read it properly. That's it. Nothing else in this code. Let's go ahead and upload it. Okay, so it's done uploading. Let's open the serial and see the values. So you see that it's printing 841, 849, 834. So this is with the amount of light we have. Now I'm going to switch off the light, and what we're expecting is that the value should go down. Let's see what happens. Now you see that the light is much less, and the value obviously has gone down to 300. So that gives you an idea how the photoresistor works. Now, if you're wondering what is the significance of 834 and 314 and whatever numbers we saw on the serial port, this equation will help us understand those numbers. First thing is a couple of statements. First is LDR is inversely proportional to light, so resistance is inversely proportional to light, and that we're going to call it R1 from the schematic. So LDR represents R1, and then R is 10 kilo ohms, which is a constant. It does not change. Therefore, in the schematic we have said R2. Now the voltage at A0, which is nothing but V0, equal to VCC into R2 by R1 plus R2. So we know the value of R2, we know the value of R1. So let's just substitute the numbers. VCC is 5 volts, and then R2 is a constant 10, and then R1 is basically your LDR. I'm putting 500 here because during dark conditions, the resistance is as high as 500 to 600 kilo ohms. So I'm just simulating that. And if you do the math, the answer is 0.1 volts. I have rounded it to 0.1 volts. So that means when the room is dark, your output is 0.1 volts. So then you're wondering, the serial port should show 0.1 volts, right? Let's see ahead. Now when the room has a lot of light, the same thing happens, and now you substitute 500 to 6 because the resistance drops, right? When the light increases, the resistance drops. So now it becomes 6 kilo ohms, and now if you do the math, the answer is 3.12 volts. Again, why does not the serial port show 3.12? Because the serial port shows what the analog pin is reading, and the analog pin can read between 0 to 1023. That is the range it can show you the values. Now if you interpolate 5 volts across 0 to 1023, roughly you can divide it into 5 portions. So what I'm doing is, if the answer is 1 volt or less than 1 volt, the value should be between 0 to 200. And if it is 2 volts, the value should be from 200 to 400. So now we had 834.35. That means that it was lying between 4 to 5 volts. And when we switched off the lights, it went to 300 and a little bit close to 200. So that means it was close to 2 volts. So that is the math behind the analog pins, the voltage, the resistance, and so on. Thank you.